So for next subtopic, we will continue for the inverse Laplace transform. So you can refer to the textbook, page 137. If Laplace ft is equal to fs, then ft is called inverse Laplace transform of fs. And this is written as Laplace inverse of fs is equal to the ft. The operator or the notation is you have the power negative at the upper side here. So this one is called as inverse Laplace transform. Laplace inverse of fs, we will obtain the ft. Okay, there are two methods on how to find the inverse Laplace transform. The first one by using table of the Laplace transform. The second one by using properties of the inverse Laplace transform. So there are also three properties for the inverse Laplace transform. So let's continue for this example. Find the inverse Laplace transform for the following expression. So you have Laplace inverse 4 over s. So we want to find what is our ft is equal to what. Okay. Example B here, Laplace inverse of 6 over s the power of 4. So we want to find what is our ft here. So for this question, we will solve by using table of the Laplace transform. Okay, for the first method, by using table of the Laplace transform, we will find the inverse Laplace transform. So we will move from the fs in order to get the ft. So we have 1, we have 2. So we will move from column 2 to the column 1. Means that if you have fs is equal to a over s, so our answer of the ft is equal to a. So let's say our fs is equal to a over s square plus a square. So our ft will become sine of at. Okay, so the same concept for the table column 3 and table column 4. The answer will move from the 4 to the 3. The same thing here. Okay, so I will explain later on how to use this table by using the example. So now let us continue for this example. Find the inverse Laplace transform for the following expression. Example A here, Laplace inverse of 4 over s. So you have to refer to the table of the Laplace transform, whereby you have a constant at the upper side, divide with s with the power of 1. So you have to know that from now, you want to move from the fs to the ft. So our question now, you have constant at the upper side, s with power 1 at the bottom side. So you must refer to the a over s, whereby our ft will become a. So I will KIV first. Example A, example B, example D. Okay, so why I KIV the A, B and D here? Because as you can see, we have a constant at the upper side here. Okay, so I will explain for the example whereby we don't have any constant at the upper side. For example 1 here, there is no problem. S here and also S here. Laplace inverse of 1 over s minus 4. So the first step, you have to refer to the table of the Laplace transform. Okay, so you have to refer whereby you have exactly the same term as you want to find the inverse Laplace transform. So you have 1 at the upper side. This one you also have 1 at the upper side. At the bottom side you have s minus 4. So you have to find whereby you have s minus something. So this is the s minus a. So from here you have to determine value of a. So if our question is s minus 4, our a is equal to 4. But if our bottom side is s plus 4, our a is equal to negative 4. So why this one is equal to negative 4? Because s plus 4 here is from s minus minus 4. So that's why our a here is equal to the negative 4. So therefore, from here, Laplace inverse of 1 over s minus 4, we know that our a is equal to 4. So our inverse Laplace transform will become exponent at. So therefore, our answer will become exponent 4t. Okay, now let us continue for the example E. Laplace inverse of s over s square minus 9. So you have to refer to the table of the Laplace transform, whereby you have s with the power 1 at the upper side, divide with s the power of 2 minus with any number at the behind here. So this is the s over s square minus a square. So you have to refer whereby you have s square minus a square. So for this one, s square plus a square, this one also s square plus a square. So if you are given s square minus with a number, so you have to refer for the s square minus a square, and also this one s square minus a square. The difference is either you have a constant at the upper side or you have s at the upper side. So for this one, we want to use the s at the upper side. So the first step, refer to the table of Laplace transform. So by refer to the table of the Laplace transform, you have s over s square minus 9. This one you have s over s square minus a square. So it means that you have to determine the value of a. So from here, determine value a. So we have 9 here. Okay, so don't include the negative here, because the negative is only for the sign for you to refer to the table of the Laplace transform. It's not the value for the negative 9. Okay, so our a here is depend for the constant here. So we have a square is equal to 9. So therefore our a is equal to 3. So we only take positive value. So therefore, we can write the answer cos h at, hyperbolic cos of at. So therefore, Laplace inverse of s over s square minus 9 will become hyperbolic cos of 3t. Next example, Laplace inverse of s over s square plus 16. So now you have to refer to the table of the Laplace transform, whereby you have s at the upper side and you have plus operation at the bottom side. So s at the upper side, at the bottom side is s square plus a square will become cos of at. So the same thing, the first step you have to refer to the table of the Laplace transform. So find for which part you have the exactly the same term that you want to find the inverse Laplace transform. So this is the same term. You have s at the upper side, s square plus a square. So now you have to determine what is our a square. A square is equal to 16. So therefore a is equal to 4. The same thing, we only take positive value. So therefore, Laplace inverse of s over s square plus 16 will become cos of at. So therefore, the answer will become cos of 4t. Okay, now let us continue back to the example A. Laplace inverse of 4 over s. So you have to refer to the table of the Laplace transform, whereby you have a constant at the upper side, divide with s power 1 at the bottom side. Okay, so by refer to the table of the Laplace transform, so this one is the suitable one, whereby you have a at the upper side, divide with s. So our answer will become a. So if you have a constant at the upper side here, there are two methods. It's either you want to bring the constant to the outside, or you can directly write the answer based on the table. So I will teach you whereby you have to bring the constant to the outside. Okay, so first bring constant to the outside. So you have 4 here. Constant 4 bring to the outside. 4 Laplace inverse. When we bring 4 to the outside, the upper side here will become 1. 1 over s. So now refer to the table of the Laplace transform. So by refer to the table of the Laplace transform, so this is the suitable one, whereby we have a over s will become a. So we have to determine what is our value of a now. So from here, we want to know what is the value of a. Okay, so a is the value at the upper side. So for this one, our a is equal to 1. So therefore, our answer will become 4, the constant at the front here, will be multiplied with the answer for the Laplace inverse of 1 over s, which is a over s will become a. So our a is equal to 1. So means that 4 multiplied with 1 will become 4. So the same thing, if you don't bring the constant to the outside here, we can directly determine our a from here, which is our a is equal to 4. So I will teach you to bring the constant to the outside, because when we go for the next example, it is easier for you if you bring the constant to the outside. Example B, Laplace inverse of 6 over s the power of 4. So you have to bring the constant to the outside first. So we bring 6 to the outside. 6 Laplace inverse. When we bring 6 to the outside, it become 1 here, divide with s the power of 4. So now refer to the table. So refer to the table whereby you have a constant at the upper side, divide with the s with a power at the bottom side. Okay, so by referring to the table, this one is the suitable, whereby you have n factorial, divide with the s with the power of n plus 1, and your answer will become t the power of n. So now you have to determine what is the value of n. So at the upper side here is n factorial, at the bottom here is n plus 1. So is it possible that our n factorial is equal to 1? No, right? Because at the bottom here we have 4. So our n here, you have to determine from the bottom side. Determine value n from s the power of n plus 1. So we have n plus 1 is equal to 4. So therefore our n is equal to 3. Once we obtain the value of n, you have to write back in terms of n factorial over s n plus 1. 6 Laplace inverse, write back in terms of n factorial s n plus 1, which will result for the t the power of n. So n factorial divide with s n plus 1, you have to write in this curly bracket. So our n is equal to 3. So n factorial here will become 3 factorial divide with Sn plus 1, S3 plus 1. Okay, so now from here, is it the same thing with the previous one? The previous one you have 1 here, but now we write as 3 factorial. So which means that when we simplify this one, it is not the same thing at the upper side here, because you have 3 factorial here. This one is 1. So if you have a number here, which is you have multiplied a number here, you have to divide back with a number at the front here. 6 Laplace inverse 3 factorial as 3 plus 1, and you have to divide back with the 3 factorial. So Laplace inverse 3 factorial over S3 plus 1 will become t the power of n. So this one will become t the power of 3. 6 over 3 factorial multiply t the power of 3. So now you have to simplify. 6 over 3 factorial will become 1. So our answer is t the power of 3. For example D here, Laplace inverse of 2 over s square plus 4. So you have a constant at the upper side here. The same thing, you have to bring the constant to the front, and then you have to refer to the table of the Laplace transform, whereby you have s square plus with a number at the bottom one and a constant at the upper side. So whereby this one is the suitable one. You have a divide with s square plus a square, and your ft will become sine of at. So the first step, we bring the constant to the front. 2 Laplace inverse. When we bring 2 at the front, the upper side will become 1 over s square plus with 4. So now refer to the table of the Laplace transform. So a over s square plus a square, you have to determine the value of a now. So a square is equal to 4. A square is equal to 4, so therefore our a is equal to 2. The same concept, we only consider a positive value. So now you have to write back in this term a over s square plus a square. 2 Laplace inverse a is equal to 2. So a here will become 2. 2 over s square plus 2 square. So now when you compare back with the previous one, it's not the same thing. Okay, the previous one is a number of 1, but now you have multiply with 2. Why you multiply with 2? Because we want to write back in the terms which is the same thing in the table of the Laplace transform. So when you multiply with 2 here, you have to divide back with 2 at the front here. 2 Laplace inverse 2 over s square plus 2 square divide with 2. So Laplace inverse of 2 over s square plus 2 square, this one will become sine 2t. So 2 over 2 can be simplified, which is will become 1. And this one will become sine of 2t. Okay, now let us continue for the next example. Find the inverse Laplace transform for the following expression. So example A here, Laplace inverse of 12 over s the power of 3. So you have to refer to the table of the Laplace transform, whereby you have a number at the upper side and you have s with a power at the bottom side. Okay, by refer to the table of the Laplace transform, so this is the suitable one, whereby you have s with the power at the bottom side. Okay, if this one is only s with the power of 1, so we want to refer whereby we have s with the power at the bottom side. So means that this is the suitable one. So you have to determine the value of n. So the first step, you have to bring the constant to the outside. So we bring 12 to the front. 12 Laplace inverse. So when we move 12 to the front, this one will become 1 over s the power of 3. So now we have to determine what is the value of n from s the power of 3. N plus 1 is equal to 3. So therefore n is equal to 2. So now we have to write back Laplace inverse of 1 over s the power of 3 in the terms of n factorial over s the power of n plus 1. So why you have to write in terms of n factorial over sn plus 1? Because we want to find the t the power of n. Therefore 12 Laplace inverse. So in this curly bracket now, we want to write in terms of n factorial over sn plus 1. So n is equal to 2. 2 factorial over s3 plus 1. When we compare 2 factorial with 1 here, this one is not the same value. So means that you multiply 2 factorial here and you have to divide back with 2 factorial at the front here. Why you have to divide back? Because we want to get back the value of 1 here. 12 Laplace inverse. 2 factorial over 3 plus 1. And then we divide back with 2 factorial. So now we have to simplify. Laplace inverse of 2 factorial over s3 plus 1. This one will become t the power of 2. 12 divided with the 2 factorial will become 6. 6 t the power of 2. So this is the answer for the inverse Laplace transform for the example A. For example C here, Laplace inverse of 4 over s square plus 9. So you have to refer to the table of the Laplace transform whereby we have a constant at the upper side and whereby we have s square plus a constant at the bottom side. So by refer to the table of the Laplace transform, so this one is the suitable one whereby we have a constant at the upper side and we have s square plus a square at the bottom side. So now we have to determine the value of a. Okay, so the value of a is the value at the bottom side. At the upper side here is a constant that you have to bring to the outside. So the first step, bring the constant to the outside, which is we bring 4 to the front. 4 Laplace inverse. This one will become 1 over s square plus with 9. So now from here, you have to determine what is the value of a. So 9 here is the a square is equal to 9. So therefore our a is equal to 3. So this one we only take positive value. So Laplace inverse of 1 over s square plus 9 square, you have to write back in the terms of a over s square plus a square. We write back in terms of a over s square plus a square because this one will give the result of sine of a t. Therefore, for Laplace inverse, a over s square plus a square, our a is equal to 3. 3 over s square plus 3 square. So now you multiply 3 here, means that you have to divide with 3 here. For Laplace inverse, 3 over s square plus 3 square, divide with 3. So now simplify. Laplace inverse of 3 over s square plus 3 square, this one will give you the result of sine of 3t. So therefore the inverse Laplace transform for the example B will become 4 over 3 of the sine 3t. So for next example, Laplace inverse of 3 over 9s square plus 4. So now you have a constant that is multiplied with the s square. So you have to refer to the table whereby you have s square plus with a number at the bottom side. Okay, so by refer to the table of the Laplace transform, the terms that you have s square plus at the bottom side is only for the part of a over s square plus a square, s over s square plus a square. Okay, but now this one is only s square. There is no number beside the s square. Means that if you have any number beside the s square, you have to bring the constant to the outside. So now there are two constants that you have to bring to the outside. First one is the constant at the upper side. We bring the constant 3 to the front. And then this 9s square, before you want to bring the 9 to the front, you have to factorize first. Okay, so first we factorize 9s square plus 4. Laplace inverse 3 over 9. So when we factorize any number beside the s square, the number still inside the curly bracket. So now we factorize 9 to the front here. So what is the terms should be in this bracket so that it will become 9s square plus 4. So we have 9 at the front here. So 9 multiply with what? So that it will become 9s square. So it should be multiplied with s square. S square plus 9 should be multiplied with what number so that it will become 4. Okay, so 9 should be multiplied with 4 over 9. Okay, so that when we multiply back 9 multiply with 4 over 9, we will obtain 4. Okay, now we can bring the constant to the outside. For example A and example B, we only bring constant at the upper side to the front. But now we have two constants, whereby constant at the upper side and constant at the bottom side. So these two constants you have to bring to the front. So the constant that should bring to the front is the 3 over 9. 3 over 9 Laplace inverse. The upper side will become 1 over s square plus 4 over 9. So now we have to refer back to the table of the Laplace transform, whereby we have a constant at the upper side and we have s square plus at the bottom side. So the suitable one is the a over s square plus a square, which is will result for the sine of a t. So we have to determine the value of a now from a square. So we have 4 over 9 here. We should determine what is our a. A square is equal to 4 over 9. So therefore a is equal to square root of 4 over 9 will become 2 over 3. So the same concept, we only consider the positive value of a. So now we have to write back the Laplace inverse of 1 over s square plus 4 over 9 in terms of a over s square plus a square. Therefore, you will obtain the result of the sine of a t. 3 over 9 Laplace inverse a over s square plus a square. Our a is equal to 2 over 3. So 2 over 3 divide with s square plus 2 over 3 the power of 2. So now you multiply 2 over 3 here. You should divide with 2 over 3 at the front here. Divide with 2 over 3. So now you have to simplify 3 over 9 over 2 over 3, and Laplace inverse of the 2 over 3 over s square plus 2 over 3 square will become sine of 80. So simplify these two terms will become 1 over 2 sine 2 over 3 t. So this is the answer for the inverse Laplace transform for the example D. So for example B here, you can do it as your own exercise. So now let's continue for the next example, example 4.8, page 138. So I will discuss example C only. For example A and example B, this one you have to continue by your own. So we have 2s over 16s square plus 25. So if you notice here, there is no symbol or notation for the Laplace inverse. So you have to write the notation for the Laplace inverse and curly bracket for the whole thing. So write Laplace inverse, curly bracket. Okay, now refer to the table of the Laplace transform, whereby we have s at the upper side and we have s square plus with a number at the bottom side. Okay, so the suitable one is the s over s square plus a square. Why we don't apply s over s square minus a square? Because this one in terms of minus, we want to solve in terms of plus. So now we have a constant 2 at the upper side, and we also have a constant beside s square. So the first thing, you have to factorize the constant beside the s square. Laplace inverse 2s over 16 bracket. So 16 here still in the curly bracket. So 16 multiply with what? So that which will become 16s square. So 16 multiply with s square plus with 16 multiply with what? So that it will become 25. So 16 multiply with 25 over 16. So now we can bring the constant 2 and the constant 16 to the front. So we will bring 2 and we will bring 16. 2 over 16 Laplace inverse s over s square plus 25 over 16. So now refer to the table of the Laplace transform. We have choose that s over s square plus a square, which will result for the cos of 80. So now you have to determine what is the value of a from the 25 over 16. A square is equal to 25 over 16. So therefore a is equal to 5 over 4. So we take the square root for the 25 over 16. So it will become 5 over 4. So now you have to write back this one in terms of s over s square plus a square. 2 over 16 Laplace inverse s over s square plus 5 over 4 square. So this one, s over s square plus 5 over 4 square, will result for the cos of 80. This one will give you the answer for the cos 5 over 4t. So therefore, simplify the whole answer. 2 over 16 will become 1 over 8 Laplace inverse of s over s square plus 5 over 4 square will become cos of 5 over 4t. Cos 5 over 4t. So this is the final answer for the inverse Laplace transform for the example C. Continue with the exercise 4.5 as your own exercise. Okay, so you don't have to submit this exercise. This one as your own practice.